GAC Pre-Cal 12, how you doing today? Hey, hope you're doing well. This is Sunday afternoon, heading into Monday. I'm extremely sorry about today. I know that for some of you, I will not be in class today, and for that, I'm very sorry. Wish I could be with y'all. However, even though I'm not with y'all, I can't say that I regret going and leaving because today, actually, this is the official and main ultrasound where we're going to see the baby and kind of check all its vital signs and that sort of thing. So we are extremely, extremely excited. Because of that, I wanted to show you something I thought y'all, at least some of you, would care. I picked up some new Nikes, and man, these are adorable little Nikes. I know, isn't that crazy for Emmy? Anyway, I'm just a proud dad. What can you say? But hey, we're going to get underway here today. Section 7.3, a little bit of section 7.4. I wanted just to touch base with you on that. And then afterwards, we'll give you some time to work on the homework. Also, the notes and the homework should be in the back. So if you don't have one, pause this video, and then we'll begin right when you press play. All right. Thank you all so much. Let's get underway. In section 7.1 and 7.2, we talked about solving systems of equations. And when we talked about systems of equations, we realized that we only had now two systems, whether it was a word problem, whether it was by graphing, whether it was by substitution or elimination. Well, today, since we have three systems of equations, we approach it a little bit differently. Now, if I was to get one like this, and if you look at the homework, the first parts of them are, those are the ones that are a little bit easier. And that's where if we have z equals 2, we literally can just plug in to the top to get what y is, and then plug in back to the top to get what x is. So again, if z equals 2, we substitute to get y plus 3 times 2 equals 5. Well, now since we have y equals 5, or y plus 5, I'm sorry, equals 5, I could subtract 5 to get y equals to 0. So I have z equals 2, y equals 0, and then I'm going to substitute back in to get x minus 2 times 0 plus 3 times 2 equals 9. So then if I simplify, I get x minus 0 plus 6 equals 9. I subtract 6 on both sides to get x equals to 3. Now again, those three, they're pretty easy. In fact, we probably have done that before. But as we start getting tougher and tougher, we're going to start realizing that it does get a little bit trickier. For instance, in the second one, notice that this three systems of equations, in the middle, there's one with only 2. In this instance, we like to isolate x on this side to get negative x equals negative 3y minus 4. And again, all I did was subtract 3y to the other side. If I were to change this sign, I can do that as long as I do it to all the other ones. It's the same as if I divided by 1, I could do it as long as I am consistent across the board. So now since I have x equals 3y plus 4, I can now take this and I can actually substitute in for both the top and the bottom. So in equation 1, what we have now is 3y plus 4, because I substituted in for x, minus 2y plus 3z equals 9. And in equation 3, again, look at the bottom, we have 2 times 3y plus 4, parentheses, minus 5y plus 5z equals 17. Now, as I keep continuing, what I can do is simplify, and notice that the y, 3y minus 2y is y. So I can get y plus 3z, and when I subtract 4, I get y plus 3z equals 5. If you see that there, when I subtract 4 to the other side and simplify. So this is the simplified number 1 equation. Number 3, we're going to distribute to get 6y plus 8 minus 5y plus 5z equals 17. And then when I simplify, I should get y plus 5z. And when I subtract 8, I should get y plus 5z equals 9. Well, noticing that in 1 and 3, we now have y and z both together, we can distribute by a negative. And when we do that, we realize that we can now eliminate. So negative y plus y is 0. Negative 3z plus 5z is plus 2z. And negative 5 plus 9 is positive 4. Once I divide by 2, I get z equals 2. Well, look at there. I've got one of the values. And just like this over here, we're going to substitute in and solve for the remaining one. So if I substitute 2 in, I get y plus 10 equals 9. That means y has to be equal to negative 1. Well, again, what do I do now? Well, if I substitute back up to the top and I go to x equals 3y plus 4, if I substitute -1 in for y, I get -3 plus 4, which gets me x equals 1. So when x equals 1, y equals -1, and z equals 2. And again, that's how I would use that to be able to solve the following equation there. Now, as you can see, it's gotten closer and closer and tougher. And I apologize for this drawing here. For those that offend, I know we need to put a little fire on there. So we'll put a little yellow and red and little orange and put a little fire to the Christmas tree, okay? Hashtag burn the trees if you follow me on Twitter. Joking, but not. As I look at this one, notice that there's no way that I can isolate one because they have all three equations. Now, this is one that I want to make sure I go over and through because it can get a little tricky, and to be honest, it is pretty difficult. First thing is this. I need to pair two of these equations together and set up two different sets, meaning I could pair 1 and 2 together and 1 and 3 together. I could pair 2 and 3 and 1 and 2. But the reality is I've got to pair them together. So what I'm going to do is I'm going to put, I'm going to do the following. I'm going to go 1 and 2. All right, we're going to put that there. And I'm going to go 2 and 3. Okay. So I'm going to put equation 1 up on top. X minus 3y plus z equals 1. And 2x minus y minus 2z equals 2. On the bottom here, let me do a different color. Let me do green here. 2, 3 would be 2x minus y minus 2z equals 2. And x plus 2y minus 3z equals -1. Now, as I look at both sets of, or both pairs, what I notice is that what can I cancel out between the x's, y's, and z's? Is there anything I could cancel out? And notice, whatever I cancel out here, I must cancel out down here. So what I'm doing now is when I cancel, I'll come up with one equation. And when I cancel here, I'll come up with a second to when then we can kind of put them together. So watch this. I'm going to multiply the top by -2. Okay, so I have -2x minus 6y minus 2z and equals -2. All right. Now, when I do that now, I could cancel, leaving me with -7y minus 4z equals 0, because these would cancel out too. All right, so we've multiplied top by -2 and we've isolated or gotten rid of y. We're going to take this equation and I'm going to bring it over here because we're going to use it in a second. Can't use it right now because we have two variables. And so we're just going to leave this one right out here when we use 1 and 2. Now, again, since I isolated this x right here, I must do it to this one too. So I'm going to multiply this one by -2 in order to isolate or get rid of that x. Okay, so multiply by -2, it should be positive 6z and plus 2 there. Okay, so it's plus 6z. Make sure it's plus. All right, so the x's cancel, leaving me with -5y plus 4z equals 4. And just like beforehand, I'm going to bring this one over here. So I should have -5y plus 4z equals 4. And again, that will be my second one. So -5y plus 4z equals 4, and we've got this one too. Well, when I paired these two together, as well as 2 and 3 together, what I was able to do was now come up with two equations with only two variables, something that we already know how to do. We notice that -4z and 4z are already set up for us to eliminate, so we can simply eliminate them to get -12y equals 4. Well, once I get to this one, I can divide by -12, divide by -12, to get me y is equal to -1/3. Okay? Now, since y equals -1/3, we can plug in anywhere and we should get the same exact answer. Okay, same exact answer. So, and what I'd like to do, I'm actually, the fact that it's a fraction, let me make sure I've got multiplied by -2. In fact, I think if I multiply by -2, I actually might have gotten this incorrect here. Let me see. Okay. So we multiply by -2 to get -2x plus 6y minus 2z equals -2. That's where I went wrong. This should be plus 5y. There we go. Sorry about that. Kind of threw me off for a second there. Actually, when I did that, plus 5y, there we go. Plus 5y minus 4z. And you might want to just check yourself, just like me. Sometimes kind of mess up a little bit when you multiply. So we got 2x minus y minus 2z equals 2. Perfect. Negative 2x minus 4y plus 6z equals 2. 4, negative 5. So negative 5y plus 4z equals 4. Perfect. And actually, this is not true. Actually, as we come up, we notice that the 5y, negative 5, actually cancel. And just like beforehand, now we've got 0 on the left side and 4 on the right. 0 does not equal 4. Therefore, we have no solution because 0 does not equal 4. But if I was to get a solution, what I could do is plug it back in to my equation to get what z is, and then use both of those to plug back in, just like I did on number 2 on this side, okay? Apologize for that. One thing to really make sure of is when you distribute, to make sure you did that completely 100% right there, all right? All right, hopefully that helped you. If you have some more questions, you could bring them in class. We will discuss them on the beginning of Tuesday there. So again, if you have any questions, please let me know, and we'll rock and roll on that. All right, last one. This one is another way. Now, again, you could do the same thing. You could pair 1, if we have 1, 2, and 3, we could pair 1 and 3 together and 1 and 2 together and do the same thing we just did. However, one other thing we can do, and again, you're going to have to know how to do both, so just so you know, is we could use what's called the matrix method. Now, in order to do the matrix method, one thing that we've done is this. We have to have something within our matrix that follows our pattern. So all the x's must be in the same row, all the columns, I'm sorry. Y's must be in the same columns, and so z must too be there as well. All right, so we have, in this case, we just take the numbers. So we have 1, 1, and 3, okay? So we'll follow that pattern, 1, 1, 3 down. Next, we'll have 1, 4, and negative 2, okay? So we'll put 1, 4, negative 2 there. And the next thing we're going to do is we're going to put in the z's. So 1, negative 1, and 2. And you don't have to put the dotted line, but that just tells me it separates the problems of variables from the solutions. But we'll also put 6, 2, and 3 here going forward. Now you might say, Coach, how does that apply? I don't really understand that. Well, the big thing again is we've got x variables, y variables, z variables, and our solutions. Okay. Now, if you don't have an x, let's say this one didn't have an x, you just simply fill in a 0 where the x is, and that's it. Okay, that would be it. So in order to follow this, what we're going to do is you're going to go into your matrix button. Okay, your matrix button. Now, if I was to see that, if you look at the x to the negative first, about right in here, where are you? Right in here, okay, you'll see that it's the matrix. So push second, and then on that, so second, x to the negative first, and you should see something that looks like this, okay, right here. Now, I want you to press enter on that. So when I press enter, apologize, actually, I'm going to go back here. You're going to go to edit, I'm sorry. You're going to actually go to edit up here. All right, go to edit. And when you do that, you're going to go right straight to A and press enter. Now, your rows and columns, you have to kind of figure out what your rows and columns are. For instance, right here I have row 1, row 2, and row 3, and column 1, 2, 3, and 4. So right now we say it's 3 rows by 4 columns. So we say it's a 3 by 4, 3 by 4. All right, so I'll kind of go back here. So in your matrix, it should have to where it's like a 3 by 4, just like this, where you put the values, x's here, y's here, z's here, and solutions, just like you see right there. So again, I'm going to go back here so I can see it. And on my calculator, I'm going to push 1, enter, and I'm just going, it actually goes across. So 1, 1, 1, and 6. And then I'm just plugging in. Okay, so we're just plugging in the variable or the coefficients in front of the variables. All right, we got that there, 3, negative 2, 2, and 3. Excellent, okay? So once I do that, I want you to quit out of that. So you're gonna just kind of push second mode, quit out of that, so where you have a blank screen. And then I want you to go back to test or second matrix again. And this time go to the math button, okay? Last time we went to edit. This time I want you to go to the math. And right below, you should be one that says RREF, which stands for row reduce echelon form. It's a way that it can help us solve it, all right? So RREF, I think it's towards the bottom. This is REF. We want it RREF, all right? So get that there. So RREF, and then go push second matrix again. And when you do that, the name should be right up here, and underneath that name, press enter, and it should be RF of A. A is the matrix that you plugged in, all right? So as you do that, you could press enter. And this is what is given to me now, all right? This is what's given to me. In my matrix, when it shoots it back out, I have 1, 0, 0, negative 1. And this one is 1, 0, or 0, 1, I'm sorry, 0, 2. Next one is 0, 0, 1, 5, okay? So I have that there. Now I've got my x variable, y variable, z variable to where x is equal to negative 1, y is equal to 2, okay, because this is the y, and z is equal to 5. So that right there allows us to find what x and y and z are by using just simple matrices to solve. All right, with this next one, I want to see if you can do it. So this time, go back to second matrix, go to edit, press enter. This time, I want to see if you can do what's on the bottom here, okay? See if you can do it. I'm going to give a couple minutes, allow the video to go, and then I'm going to show you the answer, and I want to see if you got it right, okay? All right, so 3 by 4 again. This time across should be 2, 1, negative 1, and negative 3. We have 4, negative 1. Okay, stop talking so you can go there. I feel like Dora the Explorer. No, I say that every time, but it's true. Okay, quit. Go to second matrix again. Go to the math button. Actually, I messed up there. Second matrix again. Go to the math button. Go down to REF. I think it's the B there. And I go to second matrix on the name. Remember our second matrix on the name, right? So this is what you do at the very end, right? You choose A at the end. So RREF. And then like it should say A like that. To put A in there, that's how you put it in for the name. To edit it, that's where you go. So you really go from right to left. So edit, RREF, and then get A matrices to plug in. So it should look like that on your calculator. Once I press enter, I got the following. X is equal to 0.5. I'm sorry, you could say 1/2. Y is equal to negative 3.6. And Z is equal to 0.4. And so again, if you have any questions on that, please see me either tomorrow morning or even during the time when we usually have that review. We'll have an opportunity to ask questions off the homework. And even if the homework for the classes that I'm not there on, if it's not done and it's due, and if you do it by Wednesday or Thursday, then I'm completely fine with you doing that and going from there, all right? All right, hey, I care about y'all a lot. Can't wait to see you back on Tuesday. Thank you again for being patient with me. And again, have a great day. All right, see y'all.